We're now to the last section in Unit 12, Section 12.5, which is on infinite geometric series. Now, in the last video in geometric series, we talked about finite series. We're also going to discuss infinite series. An infinite geometric series only has a sum if it converges. Write that down. There are two types of infinite geometric series. One is the one that converges. If an infinite geometric series converges, that means its common ratio r, if it converges, the absolute value of r is less than 1. If it diverges, that means the absolute value of r is greater than or equal to 1. That is your test. You must test your series to see if it converges or diverges. A couple of examples. Determine if the geometric series converges or diverges. Well, very simply, in order to find r, the common ratio, you take the second term and you divide it by the first term. In the first example, 20 plus 24 plus 28.8, etc. The second term is 24, and the first term is 20. Well, if you divide those two, you get an r value of 1.2. Therefore, since r is greater than, or the absolute value of r is greater than 1, this would be a series that diverges, and therefore it has no sum. You can't figure it out. Example 2. Does it converge or diverge? Well, to find the r value, you take the second term and you divide it by the first term. So in this case, we get 1/3, which is the second term, divided by 1, which is the first term, and you get 1/3. Now in this case, the absolute value of r is less than 1, because 1/3 is obviously tinier than 1. So therefore, this series converges, and it will have a sum. That's how you determine convergence or divergence. Now, there's a very small formula. If you know your series is infinite and you know it converges, the sum of any infinite geometric series that converges is equal to the first term divided by 1 minus the common ratio. That's it. That's it. All you got to know is the first term and the common ratio. Well, let's try that. Put that formula in a box, by the way. Highlight it, color code it. This is the sum of an infinite geometric series that converges. All right, example number 1. Let's find the sum of this infinite geometric series if it exists. Well, the first thing we got to do is we got to prove that it exists. We need to find the r value. So we take the second term and divide it by the first term, which comes out to be 0.8. And therefore, since the absolute value of r is less than 1, this series converges and will have a sum. Therefore, I use the formula I just wrote right here. The sum of this series is the first term divided by 1 minus the common ratio, which is 0.8. You just figured that out. So basically, I get the number 5 divided by 0.2. And in this particular case, 5 divided by 0.2 is 25. And therefore, that is the sum of this infinite series that never ends. And you got to remember the numbers are getting smaller and smaller and smaller. So these numbers, as they get smaller, approach the number 0. So eventually there's nothing to add to anymore. Obviously the biggest numbers are up here and the smallest numbers are way down here. Therefore you can get a sum which is 25. Last, the sum of this geometric sequence or series from n equals 1 to infinity. Now that's a new notation. Infinity up here means the series goes on forever. That means it's an infinite series. Okay, so they're telling us it's infinite. Well, very simply, the sum is equal to a sub 1 divided by the common ratio, or divided by 1 minus r. All right, now, how do you do this? Well, the common ratio, you need to find the second term. So I need to put 2 in for n. So the second term is 2 over 3 to the 2 minus 1 power, which is actually 2/3. Then I need to find the first term. So then I'm going to put the number 1 in for n, and I get 2 over 3 to the 0 power, which is equal to 2 over 1, which is 2. So my common ratio r is 2/3 divided by 2. Now, you all know when you divide by a fraction, you invert and multiply. So that's like by timesing by a half. The 2's cancel out, and I get my common ratio is 1/3. So now I can solve this problem. The sum of this infinite geometric series is the first term, which we figured out is 2, divided by 1 minus 1/3. Well, we got to do a little fraction work here. 1 minus 1/3 is very simply 2/3. And now I have 2 divided by 2/3. Well, dividing is the same as multiplying by its reciprocal. So basically, I'm just going to leave that there. I'm going to go over here. Basically, my sum is 2 times 3 over 2. Well, my 2's are going to cancel, and therefore the sum of this infinite geometric series is going to be the number 3. That's what all these numbers added together are. And that's it, people. That's it for Unit 12. That wraps up everything dealing with sequence and series.